cracks this stuff about 10 times faster than a laptop. So if I had 10 laptops here, it would be about the same speed. This also works with the version 2 format, which I just got working about 5 minutes before this talk started. So here's a second image with the version 2. This has a different passphrase. Just running on my PC right now. And there, the passphrase is file fault. And then I can also run that on the FPGA and it does everything properly. So that's my portion, I guess. Yeah. Thanks a lot.
We could switch back to the other. Great. And of course, he did forget to mention that he has a cluster of 16 of these sitting on your desk or something?
Yeah, 15.
Yeah. Of the FPGAs, right? So that's a pretty excellent improvement over about 70 keys a second. So got some other references in here. If you happen to be the author of DMG Brute, it'd be nice to meet you, talk to you. And it's all going to go up on crypto.nsa.org/vilefault shortly. Actually, probably during questions, I'll copy it over. We'd like to thank these people for their help and for their input. So thank you all, especially to my lawyer, Jennifer Granick. Our lawyer, I guess. And every person at the EFF, thank you in advance. And everyone at the CCC. And also Club Mate. So now I guess is the time when we can take some questions, if anyone has any questions.
Okay, I'm sorry by advance because I'm going to try to talk cryptography early in the morning. So it's just you didn't mention about the security of Firewall. You talked about I think you know about it, but you forgot to talk about the eventual weaknesses of the chaining mode, which is CBC, and I think there is some kinds of attacks on CBC. It was talked about a lot. In LoopOS or NDMcrypt some times ago. So yeah, you forgot about it, and maybe there is a reason, or I don't know, but I think there is some weaknesses in CBC which could lead as well to failure in Firewall.
Actually, using CBC is fine as long as you have a large enough block size. So the attacks that you usually have on CBC mode is that you have collisions, basically, that happen when you have small block size. Say you have DES and you have a 64-bit block size, then it wouldn't be a good idea to use CBC mode because you'd have a collision with a probability of 1 to the minus 32. However, for 128-bit block sizes, the probability of that happening is rather negligible. You could, of course, use other modes as well. I mean, one of the modes that you could use would be counter mode, but then you'd be kind of screwed because people could arbitrarily flip bits in your blocks, and you wouldn't know. So that's kind of a bad idea. The only thing that would really improve the security over CBC would be to switch to something the disk encryption modes that have recently been discussed and proposed in the IEEE working groups, but those are not standardized yet, as I understand it. So, well, what this comes down to is that actually Apple doesn't have much to be ashamed of cryptographically. I mean, they have a couple of slip-ups, but none of them turned out to be devastating. The iteration count could be higher, for instance. I've mentioned that already. Parts of the source code read like they couldn't really keep the different PKCS standards apart. Like in some sections of the CDSA or the CSSM source code, there's like a comment about a PKCS1 padding, where it's actually, well, PKCS1 is asymmetric, and they're talking about symmetric stuff, and it should be PKCS7 in that case. But in principle, they've stuck with well-known standards, and they have avoided some attacks as well. I mean, it's good that they use IVs that depend on the block number, actually. I mean, they could have done worse. They could have just had a counter. So the security of FileVault is, as of now, as I see it, is holding up pretty well, except for attacks that exploit the implementation, or that exploit data leakage outside of the actual container. And, of course, passphrase cracking. I also don't think that you can do much with the theoretical. I wouldn't say it's a vulnerability, but the theoretical problems that you have with Yarrow. I mean, because the security server is feeding the kernel entropy through def random, other processes can do that as well. They can, I mean, you can write like a huge chunk of zeros into your entropy pool, and this doesn't even work if you're not root. But it doesn't compromise the system, and this shows that Yarrow is kind of a robust design, and it also shows that Apple has made a good choice in choosing Yarrow, although they maybe should have modified it a little bit more, more elegantly, let's put it that way. So I hope this answers your question. Okay.
I have a question over here.
Okay.
Over here. To your left.
Oh, okay, sorry.
So there seems to be recently a lot of backlash against researchers looking at Apple stuff, as we saw by the wireless driver stuff that happened. I was wondering if any Mac fans have contacted you, or if you expect to receive any emails or anything of the sort.
Oh,
okay. Oh yeah.
I actually received an email a couple of hours ago, and I'm not. Can I?
Yeah.
I hope he's not in the audience. Okay. So I should translate. Basically, he's asking about the lecture that we're giving here, and he's stating that he's an Apple user himself, and asked what we want to show in this talk. He asked whether it's insecure. He asked whether, whether one should use this technique. Of course, I haven't replied to this mail yet, so of course, yes, Gunnar, you should use this technique. And he's complaining, I mean, he doesn't know what we're talking about, but he's complaining that we always show attacks here. I mean, what the? And he's asking whether we basically want to spread FUD. I mean, sorry, you look like a typical Apple fanboy to me. I mean, I like Apple products, but I can also be critical of them. And I think this is not, I mean, this is not only, this cannot only be seen with Apple products, but with Apple products, there's a huge amount of users that get very, very protective of their operating system and of their PowerBooks or MacBooks or whatever it is. For me, it's just like a piece of technology, and I chose it because it was good at the time for what I wanted to do, and that's it.
He answers this question in his message.
Yeah. Yeah, well, I didn't write it, sorry. Okay. More questions?
Okay, here in the back, in the middle. I just comments on the question one before. There is a problem with the constant initialization vector per block, which is theoretically just a cryptographic, malpractice.
Wait a second. It's not constant per block.
Once you choose your key, it's
Yes,
constant. So for your container, it's always the same, whatever you write into the block.
That's correct.
And the second point is the bit flipping attack is in general also possible with CBC mode. The CBC mode doesn't protect the integrity of the data.
That's correct as well. Yeah. Okay, so this wasn't really a question, but thank you for adding to the content of this talk. More questions or comments?
We should put up the source code now, I think.
Yeah.
Do you want to commit the there's people there? Do you want to unplug and commit that?
I just wanted to say there is a little tool called class dump,
Yes.
which lets you dump a header file from an Objective-C class. You can use that tool on the disk image framework itself, and there's coming some interesting stuff out of it.
That's quite correct, but have you actually done that? Have you looked at the output?
Yes?
Okay, what do you see? Because the thing is, although there is a little bit of Objective-C for the glue code, most of the stuff is implemented in C++. And you just see, when you use class dump, you just see the methods that allow you to connect to the framework, and you can't actually see inside.
Yeah, that's true.
Okay.
But still interesting, though, I think.
Well, maybe. Okay. More questions? Did we disappoint you? Did you expect Firewall to be completely broken? Can we have a vote on that? How many of you came here expecting Firewall to be totally broken? Okay. Okay, we got to try harder then.
So the source code will be live in about 5 minutes. Crypto.nsa.org.